Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam February-March 2024, paper 62. Let's start it. Question 1. Calcium carbonate is an insoluble solid. Calcium carbonate can be made by adding excess calcium chloride to an aqueous solution of sodium carbonate. So we have calcium chloride solution with sodium carbonate solution, but calcium chloride is in excess. As we can see from the equation, calcium carbonate is formed, which is insoluble, and also aqueous solution of sodium chloride. Here we have the first two steps in the student method. First, we will have sodium carbonate in the beaker, and we will add excess aqueous calcium chloride. Then we will mix the two solutions together. First, name the item of apparatus labeled A. As we can see, A is a glass rod. Suggest why the mixture is stirred in step 2. The mixture, of course, is stirred to mix the two solutions together. After step 2, the student filtered the mixture to remove the solid calcium carbonate. Of course, because calcium carbonate is an insoluble solid, so it can be removed by filtration. Then the student collect the filtrate. The filtrate will contain sodium chloride solution and the remaining calcium chloride solution, because calcium chloride was in excess. So the filtrate will contain both sodium chloride and calcium chloride. Here we want to draw a label diagram to show the apparatus used for this filtration. Here is the apparatus used. We will use filter funnel and filter paper supported in a conical flask. Of course, the calcium carbonate will remain as insoluble solid residue on the filter paper, and the filtrate will be in the conical flask. As we've just said, the filtrate will be sodium chloride plus calcium chloride. The solid calcium carbonate obtained by filtration is not pure. Identify one substance other than water which is mixed with calcium carbonate and make it impure. We can see here from the filtration, calcium carbonate will be on the filter paper, and it may have a small amount of the filtrate attached to the residue, and the filtrate contains sodium chloride and calcium chloride, so that will make calcium carbonate is impure. So to identify one substance that makes calcium carbonate is impure, it may be calcium chloride or sodium chloride. Describe how the substance you have identified in question DI can be removed from calcium carbonate. Of course, both calcium chloride and sodium chloride are soluble, so it can be removed from the solid calcium carbonate by rinse the residue of calcium carbonate with water. Describe a test that the student can do to the filtrate obtained in step C to show that the calcium chloride used in excess. Give the result of that the student will obtain if calcium chloride is in excess. If calcium chloride is in excess, so we have calcium ions in the filtrate, so we can test for the presence of calcium ions. If calcium ions present, that means that the calcium chloride is in excess. So we will add aqueous sodium hydroxide to the filtrate. If we have a white precipitate formed, that means we have calcium hydroxide formed and we have calcium ions in the solution. That means the presence of calcium chloride and calcium chloride is in excess. Then question 2. The student investigate the reaction between aqueous calcium carbonate and two different solutions of hydrochloric acid, acid A and acid B. The student does 3 experiments. Experiment 1, he rinses the burette with water, then rinse it with hydrochloric acid A, rinse the conical flask with distilled water, and he filled the burette with hydrochloric acid, run some of the acid from the burette, and record the initial reading of acid A in the burette. Using measuring cylinder, measure 25 centimeter cube of aqueous sodium carbonate, put it in a conical flask, use methyl orange indicator, stand the flask on a white tile, add hydrochloric acid slowly from the burette while swirling the flask until the solution change in color and the color of the solution becomes orange. Then record the final reading of the burette. The second experiment, or experiment 2, the student filled the burette again with hydrochloric acid and run some of the acid from the burette to record the initial reading of hydrochloric acid. Rinse the flask with distilled water and use again 25 centimeter cube of aqueous sodium carbonate. And here the student changed the indicator. He uses thymolphthalene indicator instead of methyl orange. Stand the flask on a white tile and add hydrochloric acid A from the burette until the solution change to be colorless, and again record the final reading of the burette. Experiment 3, the student repeat all the steps of experiment 1. That means he will use methyl orange indicator, 25 centimeters cube of sodium carbonate, and record the volume of the acid used in this case, but he will use dilute hydrochloric acid B instead of acid A. Here we have the burette diagrams for the 3 experiments, and we have to record the initial reading and the final reading for each experiment. For experiment 1, the initial reading, as we can see here, it's 0.8, and the final reading will be 26.2. As we can see here, 26.2. Then for experiment 2, the initial reading will be only 0.2, and the final reading will be 12.9. For experiment 3, the initial reading will be the initial reading will be 1, and the final reading will be 39.1. So we will subtract the final reading minus the initial reading for each of these experiments to get the volume of the acid used. For experiment 1, the volume of the acid used is 25.4. For experiment 2, it will be 12.7, and for experiment 3, it will be 38.1. State which solutions of dilute hydrochloric acid A or B is more concentrated, and you have to explain your answer. So here we are comparing between the solution of acid A and acid B. That means we are going to compare between experiment 1 and experiment 3. So let's check the volume used in experiment 1 and experiment 3. In experiment 1 we have 25.4, and in experiment 3 we have 38.1. That means more volume is used in experiment 3, more volume is used from acid B. That means solution A, or acid A, is more concentrated because the volume of acid A used in experiment 1 is lower or smaller than volume of acid B used in experiment 3. That means solution A is more concentrated. Deduce how many times more concentrated this solution of dilute hydrochloric acid than the other hydrochloric acid. We said that the solution of acid A used in experiment 1 is more concentrated because we use smaller volume of acid A than acid B. So to get how many times it is more concentrated, we can check how many times the volume of solution B is more than solution A. So we will divide 38.1 by 25.4. We will get 1.5. That means we use 1.5 more volume, and the concentration of the acid A in experiment 1 is 1.5 more concentrated. So acid A is 1.5 more concentrated. Compare the volume of dilute hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A also, which is used in experiment 2. The difference between experiment 1 and experiment 2, that we change the indicator used. By changing the indicator, change the volume of acid A used. So in experiment 1, we use 25.4, and in experiment 2, we only use 12.7. That means the volume used in experiment 1 is greater than experiment 2. Actually, it is twice as the volume used in experiment 2. So a greater volume used in experiment 1, the volume of acid A in experiment 1 is twice or double the volume used in experiment 2. Deduce the volume of acid B required to reach the end point if experiment 3 is repeated using thymolphenol indicator instead of methyl orange indicator. Use your answer in CI to help you. So first, we will check what will happen by changing the indicator for experiment 1 from methyl orange to thymolphenol. We use half the volume of the acid. So again, if you change the indicator of in experiment 3 of an acid B, if we change the indicator from methyl orange to thymolphenol, we have to know that we will use again half the volume. So we will divide 38.1 by 2 to get the volume used if we change the indicator from methyl orange to thymolphenol. So here, what will happen in experiment 3 if we change the indicator? We will have to use half the volume used in experiment 3, which is 19.05 centimeter cube, which can be rounded to 19.1 centimeter cube. Half the volume used in experiment 3, which is 19.1 centimeter cube. Then we'll go to question D. At the start of experiment 3, the burette is rinsed with distilled water and then with dilute hydrochloric acid B. Identify substance that removed from the burette when it is rinsed with distilled water at the start of experiment 3. The burette contain hydrochloric acid A from experiment 1 and experiment 2. So by rinsing with water, we will remove hydrochloric acid A from the previous experiments. Describe how the result of the titration would change if the burette was not rinsed with dilute hydrochloric acid B after it has been rinsed with water. If the burette is not rinsed with hydrochloric acid B, that means it will contain few drops of water remaining in the burette. That means a larger volume of acid B will be used to neutralize the sodium carbonate solution. So larger volume of acid B will be used. Explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water. The conical flask cannot be rinsed with aqueous sodium carbonate because this will add more volume or unknown volume, or it will increase the number of moles of sodium carbonate in the conical flask, and this of course will change the volume used from the burette. Explain why a white tile is used during titration. We use a white tile to see the color change at the end point more easily and more clear. Describe the effect on the result if we warm the aqueous sodium carbonate solution in experiment 1 before carrying out the titration, and you have to explain your answer. Of course, by warming the solution, we will have no effect on the result. The result is the volume of hydrochloric acid used. No effect on the volume of hydrochloric acid used because the number of moles of sodium carbonate cannot be changed by just warming the solution. And the titration is a quantitative process. We are concerning about only the number of moles. So heating the solution or warming the solution will not change the number of moles of sodium carbonate, and we will have no effect on the results. Then we'll go to question 3. A student tests two substances which are solid C and solid D. Solid C is ammonium iodide. The student dissolves solid C in water to form solution C and then divide solution C into 3 approximately equal portions. First, the first portion of solution C, the student add 1 centimeter dilute nitric acid followed by barium nitrate. We know that barium nitrate is used to test for the presence of sulfate ions, and here we have no sulfate, so the observation will be no change. To the second portion, again, he add 1 centimeter of dilute nitric acid followed by silver nitrate. We know that silver nitrate is used to test for the presence of halide ions. Here we have iodide ions, which will form a precipitate of silver iodide. So we will have an observation which is yellow precipitate is formed. The precipitate, of course, is silver iodide. To the third portion of solution, the student add an excess aqueous sodium hydroxide, and of course here we will have no precipitate, so we will write the observation no change. And the student warm the solution produced from CI and test for any gas given off. When we warm the solution contain ammonium ion with sodium hydroxide, ammonia gas is produced, so the observation a gas produced which change the red litmus paper to blue. Then test on solid D. Here we have a table which shows the students' observations for solid D. First, he do a flame test on solid D. It gives a yellow colored flame, and the yellow color is the color characteristic for sodium ions. So we have sodium ions present. Gently heat about half the remaining solid D, then hold the strip of anhydrous cobalt chloride paper on the mouth of the boiling tube. By heating the remaining of the solid D, steam is given off and condensation form on the on the top or the mouth of the boiling tube. That means solid D is hydrated, and by heating solid D, steam is given off, which again condense on the top of the test tube. Hydrated solid contain water, so we can test for this water using the anhydrous cobalt chloride, and the color of the anhydrous cobalt chloride change. Of course, the anhydrous cobalt chloride is blue, and when it touches water, it forms pink color, so the color will change from blue to pink. Test number 3. Dissolve the remaining solid D in water to form solution D, and divide solution D into 3 portions. The first portion, we add ammonia dropwise until in excess. A green precipitate which is insoluble in excess. A green precipitate of course indicates the presence of iron +2 ions. The second portion of solution D, add aluminium foil and about 5 cm³ aqueous sodium hydroxide, and this is the test for the nitrate ions. Heat the mixture and hold damp red litmus paper to the mouth of the boiling tube. By adding aqueous sodium hydroxide, of course a green precipitate will form again, but we will test for the presence of nitrate ion if ammonia gas is present by holding a damp red litmus paper on the mouth of the test tube. Here the red litmus paper remains red. That means no change in color in of the red litmus paper, no ammonia gas produced. That means we don't have any nitrate ions. Test 5. To the third portion of solution D, add dilute nitric acid and 5 cm of dilute nitric acid and bubble the gas formed through lime water. When we add nitric acid, we can see effervescence of a gas which turns lime water milky. That means this gas is carbon dioxide gas. The first question is, state the final color of the cobalt 2 chloride paper in test 2. That here we can see that the anhydrous cobalt chloride changed to hydrated cobalt chloride, so the color changed from blue to pink, and the final color will be pink. State what ion the observation in test 4 show it is not present. Here in test 4, the test shows that we don't have nitrate ions because the color of the litmus paper doesn't change, so no ammonia gas is produced, so we don't have any nitrate ions. So test 4 shows that we don't have any nitrate ions. The gas formed in test 5, as we've just said, the gas that changed the lime water to milky is carbon dioxide gas. Identify the 3 ions present in solid D. First, we have sodium ions because we have yellow color in the flame test. Second, we have iron 2 ions because we have a green precipitate formed with the addition of sodium hydroxide, and the precipitate is insoluble in excess. And third, we have carbonate ions because carbon dioxide gas is formed by addition of nitric acid, so we have carbonate ions. So the 3 ions present here are sodium ions, iron 2 ions, and carbonate ions. Question 4, which is writing investigation or experiment. When excess dilute sulfuric acid is added to solid zinc, hydrogen gas is produced, and of course we have also zinc sulfate. Plan experiment to show that copper can be used as a catalyst for this reaction. Your plan should include how the results of the experiment will show that copper is a catalyst for this reaction. You can show that copper is a catalyst if copper remains unchanged, the same mass after the experiment finished, and if copper increase the rate of reaction. So to show that copper is a catalyst, you have to prove these 2 points. First, it remains unchanged, and second, it increases the rate of reaction. You are provided with zinc powder, dilute sulfuric acid, copper powder, and all common laboratory apparatus. So to write this investigation, first, we will put a known mass of zinc in a conical flask and connect the conical flask to a gas syringe. Add a known volume of sulfuric acid to the flask. Now the hydrogen gas will be produced, and we will measure the volume of hydrogen gas collected after any set of time. Let's say it's 30 seconds. So we will collect the volume of collect and measure the volume of hydrogen gas produced after 30 seconds. Then we will repeat the experiment using the same mass of zinc and of course the same volume of sulfuric acid, but we will add a known mass of copper to test if copper is a catalyst for this experiment. Again, we will record the volume of hydrogen gas produced after the same time, which is 30 seconds. We will record the volume of hydrogen gas after 30 seconds. Then we will filter out the copper from the solution because copper is solid, so it can be filtered. And we will wash it with distilled water, dry it, and wait to record the final mass of copper. Copper can be a catalyst for this reaction. If the mass of copper doesn't change, that means we have the same mass, the initial mass equal to the final mass of copper after the experiment finished. And if copper produce more hydrogen gas in the second experiment, that means we have more hydrogen gas is collected in 30 seconds in the presence of copper. That means copper increase the rate of reaction and it remains unchanged at the end. Copper can be used as a catalyst for this reaction. Here we come to the end of our exam. Comment down below if you have any questions. Like the video and subscribe to the channel to receive all the updates. Thank you for watching. Wish you all best of luck.